Audio check. Audio check.
Can everybody hear me?
Yes.
I can hear you.
Wonderful. Okay, let's make a start. So hello and welcome everybody to the next in our series of Drone On powered by Feds and with our partners today, Pix4D. The title and the subject for Drone On for today is bigger data sets with quick results, how to tackle processing large batches of drone data using Pix4Dmatic. So moving on to the next slide. So very quickly, what is Drone On? For those that are new or have already been part of the series, just to repeat that Drone On is here to support and educate those interested in drone and related technologies that can support and develop your business. So all those questions you've got burning on your mind that we'd like the answers to understand our products, keep in touch with what's current in the market, we're here to help you. Next slide, please. So during the presentation, please confirm to us that you can hear the presentation correctly and let us know if you have any issues or questions on the chat section as shown here. We're very pleased to answer this for you and we have a team ready to do so. Please feel free to ask questions during the actual presentation. There will be polls as well. So feel free to go ahead and do those, but not to forget that we will also have a summary question and answers session at the end. And at this point as well, we'll try and address any further questions we have that might need a little bit more detail. Also to advise you that a copy of this webinar will be recorded and sent to all of the participants at the end of the session as well. Next slide, please. So moving on to our hosts that we have here with us today. As you can see, myself, Dan Casey, I'm the Business Development Manager for Feds Middle East. Here working with my partner, Jude Searchfield, who's our Specialist Product Sales Manager. Majority of this will also be hosted today by our specialist and co-presenter, Gabriel Ruggiero from our partner Pix4D, supported by Nate Moore, his Senior Product Manager, and Pigrolino as well on products as a further co-presenter. So today's Drone On webinar includes who are Feds and Pix4D, which we've started on, but we'll get into a bit further shortly. Obviously, drone data processing theory, processing solutions, an introduction to Pix4Dmatic, a live demo, so we can interact with it, Pix4Dmatic and Pix4Dsurvey integration, and finally an analysis of it, and of course the Q&A and summary at the end. So here's a quick summary about Pix4D, Feds, I do apologize. Feds are a 6 going on 7-year-old specialist drone company based in Dubai and all across the Middle East region. We've grown from a startup business to having 35 specialist drone pilots, engineers, data processors, and remaining team. Feds have also had an acquisition from a partner company called Aradyne, and together we've now formed pretty much the largest drone company on the planet. So a very rapidly growing company within a rapidly growing industry, and leading the way in terms of the technology, hardware and software that are offered within this region. Feds are a drone solutions company. So this includes everything from top to bottom. I think we've lost the slide, just bear with us. Okay, thank you. So Feds are a complete solution company, including services, products, training, licensing, etc. Full range of everything drones, from drone surveys and mapping, drone inspections, progress monitoring, supply and training, and of course, as we're focusing on today, software. Just to explain that the relationship between Pix4D and Feds is such that we are the master dealers for the software in the region. So essentially Feds are Pix4D for the Middle East. We can supply you all of the products within the range, support, advice, etc., hand in hand with the team that you have with us today. So now I'd like to hand you over to Gabrielle, our account manager working with Feds, to take you through the solutions.
Hello, everybody. Hope that you can see my screen and that everything is fine. So I'm very happy and pleased to present here together with my colleagues, Nate and Pierangelo. And we'll talk about a little bit about the software, and we definitely will see the demos, the live demos of the software itself. So with Pix4D, is a global company and leader in professional photogrammetry software for drone mapping. Started in 2011, so this year we're going to celebrate the 10th year. And we are now about 180 employees, a little bit more. Then we speak a lot of languages. We are international. We basically have offices in the headquarters in Switzerland. Then we have representative offices all around the world to cover basically the time zones, all the time zones of the world for support, business, and R&D goals. Our goal is definitely R&D focus, so we provide software. So we don't provide services, we don't provide drones itself, and we definitely work with our network of resellers all around the world. In 2012, we had a kick-off basically investment from Parrot, and we are part of the Parrot group afterwards. So around the world, we have more than 60,000 clients working with our software on a daily basis. And in 2019, we had a revenue global turnover of 25 million. We do a lot of trainings. We do industry-specific software and trainings about that. So we are not bound with a specific drone, so we can support the business of everybody. Let's go on with that. So now I just want to go to the first poll. It's a short one. Please, Ali, if you can set the poll for the audience. Yeah. Here is the poll. So what processing software you currently use to process your drone data? Pix4D Mapper, Drone Deploy, Agisoft, Bentley, DJI Terra, or whatever else. So it's going to be just good to know for us. So we simply want to address these questions quickly. Okay, thank you. So let's go. The quick presentation of what is photogrammetry. Drones are based, on GPSs and images. So drones have the two ingredients that actually are enough to create the 3D model and the 2D maps, collecting a lot of images from a top view. The software uses geometries and the texture together with the GPS of the drone in order to generate the 3D. This is a quick 30 seconds intro of what photogrammetry is. So now it's the turn of my colleague Pierangelo that will present us Pix4Dmatic. Please, Pierangelo.
Hello, everyone. I'm glad to be here. As Gabriele said, I'm going to present Pix4Dmatic, which is our new software for handling really large data sets, and it's specific also for corridor mapping, such as long highways or train lines or anything that is a corridor. So it's really good at this. Our aim is to be, for those who know Pix4D Mapper, our aim is to be 10 times faster. This includes processing, but also the interaction you have with the software when you load data, when you mark ground control points. Really, the whole experience should be faster while keeping the same accuracy. And also related to this, we also want to be more reliable. And here, one typical example is that for really large data sets of 10,000 images or more, Pix4D Mapper, in Pix4D Mapper, you would usually have to split it into smaller projects, whereas in Pix4Dmatic, it can just handle all images in one go. So it's also more stable in this regard, and it will accelerate your workflow here. A good news for those who are on macOS, we support both Windows and macOS now fully. So this is really something which will enable you to use the software and be more flexible on more platforms. Okay, so that was for me the introduction. Can you please switch the slide, Gab? So as I hinted towards, we can have bigger data sets. This is particularly useful in corridor mapping, but also if you have, for example, a huge mining site or a big map to do anywhere. This will save you time and your workflow will be better while keeping the accurate results. And I will show you in the demo what kind of things you can do to keep and ensure the accuracy. But for sure, the checkpoints are available, ground control points, also a quality report. So all the tools you need to check. Its processing is automated. What does it mean? You still keep the control of what you do. You have settings, you can select what you want to do. But once you set all the settings, you can click start and it does the job for you. You can, of course, always check the results, interact with it, but there is some kind of automation available. And the third, but not least of the points is the fact that we managed to run so many images at the same time also makes it future-proof for beyond visual line of sight mapping. What is this? For those who don't know, it's when you can fly the drone out of sight, which will enable you to cover larger distances and bigger areas. This is not yet authorized in all countries, but we see the trend starting. And for those who can already, it's really a good tool there. Next slide, please. Okay, so here, if you would like to read more about it, we have a use case on our website where we acquired together with SenseFly, with the NIBIX, a 10,000 images data set. There is some agricultural part, there is a town, so that you really see that it can work in different kinds of environments. And here we also compared this data set on other competing software, and most of them didn't even manage to complete the processing. So here it's really this example of how reliable the software is, even with big data sets. So it's not only able to process it, but also the interaction with it. When you, for example, look at the point cloud, everything is optimized so that you have a really good experience. So I hope this will make you try the software as well, so that you can see it yourself also on your own data. And
Perfect.
now I'm giving the talk to Gabriele, who is going to present you a concrete example.
Yeah, so thank you very much. So this is we know that we have both, everybody has to believe in the local data sets. Okay, so of course we did that in Switzerland, but what about over there in the UAE? So this is a project that FED's team had the chance to conduct as a land survey and map of the biggest quarry limestone located in the Ras Al Khaimah. I hope that I pronounced it properly. Basically covering an area of 13.7 square kilometers. The area was in total. So this is a very, very big area with that has been performed in multiple flights, of course, with a SenseFly EBX drone. So it's a fixed wing drone, and collecting 6,200 images. It's over there. So there is also a case study that Feds did with it, and it's published on their website. The interesting thing here is that we asked, of course, Feds to run the same project that was done even before the software of Pix4Dmatic was basically launched. We asked them to reprocess on that, and it was really, really cool. I mean, we will tell you later about what are the flights. So let's go a little bit deeper in the software, in the project itself. So 4 teams, 4 expert drone pilots, 2 teams, 3 areas that 3 sub areas that the project has been divided into, and flying the drone at about 120 meters height with a very good normal overlap helped them to achieve basically a 3.3 centimeters accuracy level with the GSD that we've seen before, with more, with the calibration and the first step of processing of 10 hours. So the interesting thing here is that the orthomosaic was also generated together with the DSM, and in really a fraction of the time that was used for the software, with the normal software. So the set of images were flown and acquired in about 20-30 minutes each, and for basically in one day, the Fed's experts, drone pilots, acquired and surveyed an area that was previously surveyed in basically 2 months. Only 25 ground control points were used, and basically were led to that type of accuracy. A lot of them were used as checkpoints, and the results are pretty cool. So this is a global orthomosaic. As you can see, all the images have been calibrated, and the interesting thing here, it may sound a bit big in terms of hours of processing, but the entire processing took 31 hours. Whereas previously, the global turnaround from images to results were about 120. That's pretty good amount of time saved. This is a global view of the project. As you can see, all the dots, green and blue, that you see here are the calibrated images that you can also see on the left, on the right side of the panel. Here you see the images and the 3D point cloud. Pierangelo, let's go for, let's show to the people how the software is.
Thank you, Gabriele. I'm gonna share my screen. Okay. Now you see my screen, I believe. Can you see Pix4Dmatic? Yes. Okay, so that's the result we're going to get to, and I'm going to show you how we are going to get there from the start. First, I'm going to create a project. Here you see that you can either select images or select folders. To create the project, I will simply drag and drop all the folders I have here. So I have 6 flights. This was a project in Italy of one of our customers who was nice to share it with us. So here I drag and drop, it was 846 images. I drop it and directly you can create the project. So here I will write demo feds. I can select where I want to save it and I start. Now the images are going to be imported in the project. So at the top you see the bar loading, it's pretty quick. And in less than 30 seconds, we already created the project now. So that's pretty nice. What's missing here is that I need to add the ground control points. So here again, I can select from disk the file, or I can drag and drop it. For you to know how this looks like, it's really a classical GCP file. You have the name in the first column, and then you have the 3 coordinates of the GCP. You can also add accuracy values afterwards for horizontal and vertical accuracy. Otherwise, there will be a default selected in Pix4Dmatic. So here, GCP file, here we go. The one at the bottom, I drag and drop it. And then it lets me select the coordinate system for this GCP. For me, this was the EPSG 30,632. And then you have also vertical coordinate system references. Here, what you have to note is that you can also, from now on, select GeoID files. We support the most common ones already, and we will support more in the future. If there is one that you would like to see supported, please just write us and we'll see what we can do. The advantage of this is that for especially for large data sets, you will have higher vertical accuracy because the coordinate systems will be better handled, and you will have really the curvature of the Earth that is also taken into account in your long corridors or big data sets. So this is really useful here. Now I click apply, and you will see directly all the GCPs are loaded. You have a default accuracy of 2 centimeters that is displayed, and you can see all of them here. So this type points table is really something new, but also really practical for when you will mark GCPs, because here at the right now there are no values in it, but you will see once I go to marking that actually while I am marking, you will have a live error indication for the reprojection error and the position error in all axes. So this will really tell you how good also the quality of your marking is, and if you need to double check your clicks. Something else that is really useful here to know is you can change a GCP to a checkpoint. A checkpoint will not be taken into account in the processing and is really there for assessing the accuracy at the end. So it's comparing the checkpoint to the results you created. This is really one of the ways I mentioned to assess the accuracy of your project. And the GCPs, of course, is also a way to ensure that it's really grounded in reality. Okay, so this is the type points table. Now, something new here is that if we want to, we can already start marking before calibration. And you noticed here at the top, I can show you again, all the blue dots at the top are the images, and they're directly geolocated and displayed even if there was no processing done. So this already helps you to see if there is an issue in terms of geolocation of the images and or the GCPs. So here you see it seems to make sense. They are at the same place. And so I'm confident too that they can continue the project from there on. Now, usually you would start marking GCPs after the calibration was done, but here you have the possibility to already start it before. I will quickly show you how this can be done. You can either click here on mark type points, or there are shortcuts to make this faster. You can click Control, Shift, and M. You go into this marking, and then you can also zoom in with Alt and scroll, or you have at the top here the zoom slider that zooms all the images. You can, of course, also zoom in a single image. So here I see the target. The thing is that as I didn't calibrate yet, the approximation of the position is a bit less accurate. So here it will depend on your project if you want to mark it before or after the calibration. It's just good to know that this exists. I will show you now how this looks like after it was calibrated, and I will then mark the GCP there. Okay, so here you saw how we created the project. Now I'm going into the And maybe something else I can show you before there is the processing options. Here I need to remove our friend Gabriele. I guess you see him too. Here at the right, at the top right in this blue button, you have the processing options, which enable you to select what you want as options as parameters. So you have the image scale in the calibration. This is similar to what you know in Pix4D Mapper. Usually it's the one image scale that you use, but if you have, for example, 42 megapixel camera images, you will do half, which will be good enough. Then you have also the number of key points that is either automatic and it will take as many as possible, or custom. If you change this, you can, for example, speed up the processing in certain cases. You also have the possibility to re-optimize the cameras. This is what we'll show you later. Then you have, of course, options for densification, but also the DSM and orthomosaic. And here at the end, you have also all the export possibilities, which are really practical for when you want to select if you want to have, for example, tiled orthomosaic or everything in a single file. So here you have many options to even select the number of pixels for a tile and the compression rate of the final orthomosaic. And you can select where you want to save it. The same is available for the DSM and the dense point cloud as well. Okay, so now let's assume I click on calibrate. I select my options for the calibration, and then I click start. I won't do it right now because I already pre-processed it for you, but here we go. So here, that's what you would see. You would see the automatic type points, which are the result of the calibration. And here I can, if I want, start marking manual type points. So here, let's see, I'll show you this example as well. I will come back to the ground control point marking in a minute, but here you also see how to mark manual type points. Let's say I want to mark it here on this white spot that seems recognizable in more than one image. I can right click and there click on add and mark new type point. And what's really nice here is that actually after a single mark I added, you can already have a reprojection on other images. Typically software requires to have 2 marks, but here it's really one way that it already improved. And manual type points really help you to assess if the reprojection error is good or not. Here I would click again and you see, I see quite a few images and the marking is really, really fast. So I can move ahead like this. Here it seems more or less okay. And like that I'm done. And then I can just click done or hit enter and I have marked my manual type point. As soon as you mark manual type point, it will say outdated reconstruction. Why? Because we provided more information to the software, and in this case, you would need to use this re-optimize button I mentioned before. Now, another marking I want to show you is the one of GCPs. So we went to it before. See here that the 3D shows you directly which images see this specific GCP. And I will move into marking mode. Here, mark type points. And I will reshuffle the images with Control R. Zoom out a bit to find my target. Here it is. I find it. And then I can start marking. Now I have a reprojection here too. Second one here. So once I have 2 marks, I reshuffle the images, and now I have a really better indication of where the GCP is. And now I can just control if the 2 first marks were enough or not. Here I need to refine the marking a little bit. Okay, I think you got how this works. And here at the bottom, what you need to pay attention to is the live error estimates. So here we see that actually the Z error is pretty high. This is nothing to worry about. This just shows that if I move to the 3D, this shows that the there was a shift between the images and the GCPs. And as you see here, the GCP is below the point cloud, and actually the marking of the GCP and the re-optimization that we will do will fix this. So this is really something that shows you while you are marking how off the GCPs and the current set is, but also how accurately you mark with the reprojection error. And once I hit re-optimize, and once I marked my images, the new optimized values will be displayed, and I will show you this directly in the full project I have here. So here I marked a few more clicks, and on the right you see that the reprojection error, once you re-optimize, is really below 1, which is good, and the position error is also really low. So here this table is useful, as you can always check if you need to correct the marking or not. Here in this case, everything is fine. On the right sidebar, you also have an indication of the quality report. You see that the mean GCP root mean square error is really low, below 2 centimeters, and the GST in this project was 7.3 centimeters. You also have an indication of how well the camera was optimized. And you have at the top an export of the quality report, which will indicate you more about the details of the processing time and all the results of your project. I can briefly show it to you. Right now, this is a text file. We're going to work on making this a PDF for the future, but right now it really summarizes all the details on the errors of the GCP, all the settings you used, and it's a good, basically, summary of your project. So this project on my laptop took around 4 hours and 30 minutes for the whole processing from calibration to the DSM and orthomosaic. I'm going to show you this in more detail now. So you have here the dense point cloud. You can zoom in and you see that even for a big data set, it's loading really fast. I'm on my laptop here. You can look at all the details. I can go to the 2D view, and here that's the orthomosaic. I can zoom in. It's really loading fast. You can see everything. The orthomosaic step itself took only 32 minutes for this 800 and something images project. You see the images count at the top. And you can also see the DSM. You can go in the content panel and disable the orthomosaic. And here you see the DSM. So you see the different heights in this project. Okay. What else can I show you? So maybe the good step here is to show you the transition to Pix4Dsurvey, which here at the top you can click on File and then Open in Pix4Dsurvey. If I click it, it will directly open Survey and enable me to start a project in there. And from there on, I will give the floor to Nathan, who will present you how the next steps are from there in Pix4Dsurvey.
Thank you, Pierangelo. Just quickly, before leaving the word to Nate, if we can go live also with the poll on number 2, please. Yep. So the question here is, how long does it take to process your average project? This is for you guys. And then later on, if you want to share how many images, usually it's your average drone project. Yeah, good. Good, thank you. So we are in the order of days, so it's interesting. Please, Nate, let's tell us a little bit about Pix4Dsurvey.
Gladly. Actually, we have some slides.
Let's go with the slides.
Yeah.
First.
Do you have those handy? Shall I stop?
Yes, I get it here.
Sorry. So yeah, Pix4Dsurvey, meanwhile, is it's a really seamless transition from Matic, like you saw. We actually use all the same file formats, everything. And in fact, if you want to take your project from Pix4Dmatic over to Pix4Dsurvey, you just need to run calibration and the densification. And that point cloud that's created in the background, that's our own file format, so we can already read that directly. You don't even have to go as far as creating that LAS file. That's an optional thing to be able to share it out with anybody else that you might need to. So Pix4Dsurvey is really going to let you take your photogrammetry, take your LiDAR or whatever kind of other point clouds you might have and do your vectorization. We're not in the business of point cloud creation or anything like creating the DSM. You'll see we do have a terrain workflow, but it's a bit different. So if we can go to that next slide. It's all about extraction and making it possible for you to do the analysis. So a reason for that is that we heard from a lot of our customers that they could do everything they needed in Pix4D Mapper, for example, which is a fully supported input to Pix4Dsurvey. Your entire Pix4D Mapper project will come through nicely. But they were getting really stuck because they weren't delivering the point cloud to their customers because it was just too big for the customer to handle. So they needed a way to make sense of all the data that they had and were creating and to be able to hand that on to the next person in their workflow. And that's where Pix4Dsurvey comes in, is really to make it possible to reduce the weight of your project effectively, to make it simple to extract the things that you really need, and to hand off that correct information to the person that you need. So we've gone the route of making that possible from the point cloud, but also from the images. So I'll show you about a little bit about how that works, what the manual options are to do that vectorization and editing while using all that stuff. I'm going to show you in the same project that you saw from Pierangelo, that Italian project up in a mountain valley. But we have some great use cases on our website about a few other things that you can do as an example with Pix4Dsurvey. So in this particular one about solar panel installation, they used Survey to get really detailed elevation models of just the roof. So you've got the visibility, the details that you can see from the images. So that really enables you to work at all different scales. So I'm going to show you kind of the entire region option in that big project from Pierangelo. But yeah, you can really easily use Survey to extract all the correct information. That's these small things that you can see in your images. So that's really the benefit of having the point cloud plus the images. You can work at the scale that you need. So that said, one thing we also mentioned there was time savings, and that's kind of our big goal here. So we are bringing more and more automation tools, but I think you'll find that the manual tools already will let you work quickly the way you need to. So let me share my screen here, and there we are. So as you can see here, this is a really similar interface to what you just saw in Pix4Dmatic. We are developers all working together, and we're really trying to keep it a consistent experience for you guys all the way through. So we've got the point cloud, we've got the images, and we understand that relationship between them. Now, I haven't done an awful lot in this project. I just opened it up, brought it in here, and I started to do just a little bit of vectorizing because I just wanted to show you guys some of the possibilities in here. So just as a first example, I came in, and this was just to show you really the editing workflow and the level of detail that you're able to see. So you can see I really quickly just created a polygon here on top of this roof on the one side. And then I wanted to be sure that I had actually vectorized everything accurately. So you can pick a single vertex and really interrogate it within the images to make sure that you placed it in the right spot. So in this case, if you can see I wanted it just a little bit back from the roof edge. I wanted to make sure that I actually got proper 3D, because in this case, you can see there's not only a big drop, but a bit of an overhang on this particular building. So you can adjust that in the images as much as you need to, and let me show you that here. So in this case, these are actually two polygons. I don't know if you can see that very well. They're just two adjacent polygons. But if I needed to come in, maybe on the corner here, it's a bit more visible, and refine this out to here. So at the moment, this is based on the point cloud, but if I start to move it here really out to the edge, just because I can see that in the image, so I know that it should be possible, then you can see we understand how it should fit in all the other images as well, and I can start to refine it a bit. And so now I've broken that connection from the point cloud, but because we understand how these images relate to each other, I've actually created a new location and I can really get it exactly where I need it to be. So you can really be as precise as you need to. If you want to work quickly, do it off the point cloud. If you want to be super precise, come on over and adjust it in the images. Now, if you need to vectorize some other stuff, like maybe your guy was out here in the field and saw, let's see, I'm hoping to find like a manhole or something here. I don't see anything that distinctive, but over here, by the river, maybe they came here in the corner and vectorized that bit of, well, that's not a great example. That's a wall. Anyway, imagine, let's just slide that guy over to here. You can also, I should mention, see what you're doing as you're modifying all this stuff in the point cloud. It does update live in the images. So you can see here, if we move it over to, oh, let's put it on that. Sorry, I'm looking too many places at once here. Let's put it on a rock where we can really see what we're up to right there. That's a nice rock down in the riverway. And in this case, if you have a known coordinate for this, you know that they actually recorded it at not 388.991, but it was just 0.98. So you can really manually adjust these so that you can nail that exact elevation that you need it to be. And so as you make these edits, these are tiny ones, it's actually moving in 3D. So you can always get the exact location you need, either for a marker or for an individual vertex. It's always going to be applied perfectly, however you want that to go in. Now, that's all fine and dandy. That's a very manual marking kind of a process. And you'll find that the UI inside Survey is a little bit different than what you might have done in, say, Pix4D Mapper before. So we've tried to make the tools, even for this manual vectorization, so that you can really just work along really quickly, just the way that you're able to, say, vectorize. I'll just quickly do something here. Right along here, you can get in, you can adjust your view, and as you move along, we've given you the tools so that you can really, without having to use a lot of different commands or anything like that, you can very quickly vectorize what you see and do what you need to. Now, one other thing you might have noticed, in this case, I just put this on the breakline layer, so you can add layers as you need to, and those will all be respected as you work along in the rest of your workflow. So if you take this project and export it, say, to a DXF file so that you can put it into your GIS or CAD, that'll respect the layer names and everything will go along the same way. Same story, if you export the project to shapefile, we'll break it up according to your content so you don't have to go back and resort all of your information later. What you're seeing here, all these blue marks, this is part of our terrain workflow, which you've got on the right side of your screen here. It's not open by default, but once you either hit the blue button here, you can pop it open, or before you've created stuff here, you'll see those, you'll see them in blue with little hints to bring you across to the processing menu. So what I did first was I did this detect and delete outliers. So that really helps you remove those really distant, really isolated points. They're probably really difficult to see by eye, and that's kind of the point. In this case, there were only 20 of them. It's quite a clean data set, so there wasn't a lot of that really distant noise, but it's really quite common, and it does have an impact on other parts of the processing flow. From there, I did the terrain filter, and let me show you what that means. So in this case, it's just ground and non-ground. That's the only kind of classification that we're trying to do with that. And that's what we see here with the yellow and blue. Personally, I like to toggle it so that we can see the terrain in natural color and the non-terrain stuff in this blue, just so that I can understand what's going to be included in the tin of the surface as I move forward. So that's up to you how you want to do it. You can also completely turn it off, and then there's no question what's going to be in the next part of your workflow or not. But again, that's all just visual stuff. But what we've done here is we've really tried to, we realize that for surveyors, so often it doesn't matter if a thing is a car or a tree, you just don't want it to be in your output, right? You just want to keep the ground. And we also have a few simple little tools, like in here, I can see there's some stuff that looks like it probably should be terrain, but wasn't. So if you are in the newest version of Survey that was just released yesterday, it was preview 1.7. So just control, mouse click, you can pick and then assign it to terrain in this case. And then if we take a look, yep, that was just grass. It wasn't classified right. So you can really easily do the cleanup that you need to. And you maybe even like here, it looks like maybe some shrubbery around the bottom of the building got included as non-terrain, but then so a bit of ground here did too. So you can really easily just grab it and put it in the right category so that you're able to get the right results. So we're trying to bring you the QA tools that make this simple as we go. Now, back to the terrain flow. So I did this terrain filter that did take a few minutes. I'm not going to show you now. A grid of points is as easy as it sounds. So if we look here, I had it on a moment ago. This blue layer is just this regular grid. Sample distance, I think, was not 1 meter, in fact, but 5. And it's just what it seems like. We got, because it's a bigger project, 89,000 points. And it's just points that came from the terrain as an input. So if you're going to create a surface or something in another tool, super simple from here. You can export this out to DXF and bring it on into the next part of your workflow. Maybe you want to bring it in as an LES. You've got options here to take out just these blue marks that we see here. But personally, I would suggest that you at least give a try to finishing the workflow here in Pix4Dsurvey. So the other option you have is the Smart Grid, which what it attempts to do, and it does quite a nice job, is identify points in the terrain class where there's the most elevation change. So this will really take you towards an even lighter weight set of points, and in turn a set that more closely represents the important points in your project. So if you're a surveyor and you're used to going out in the field and capturing those high points, low points, and any natural break lines, this will effectively do the same thing. So definitely give that a try. And then once you have those grids, you can go ahead and make a tin of the whole thing. So like if we look here at the tin, it generates really quickly. And you can see in the case of the field here, nice and clean. And in terms of, let's see, what did I do here? This is my fault. I put the building in the breakline layer. That obviously doesn't make any sense. Okay, let me really quickly move that out to layer 1. And then we'll actually be able to see that difference quite nicely if we regenerate the tin. Should be nice and flat there. And you can see it does make a huge difference in what that looks like. We need to do a little bit of cleanup around here, but in fact, there was a, it's complicated here. There's this ramp going into the second level, and then this roadway that goes underneath. So the actual 3D setup is a bit complicated. So the point cloud could use a little cleanup help there to make everything work nicely. What's really cool, I think, in this version is exactly what I was just showing you. This terrain layer is getting treated as break lines. So if we look here, same kind of a story, except in this case, I vectorized in some actual break lines. So if you look at this, I won't make you do the actual review of it right now at the moment. You can see there is actually a bit of an edge here just below the road. It's a decent hillside. And we also have this nicely spaced grid of points. So in this case, if we look at the tin, you can see it fits really nicely exactly how it should go. Now, of course, you can always refine it more. You can always work on it a bit. But for me, it already captured everything really well. If we were to run the smart grid of points, you can see here where it flattens out a bit, it would tend to put points along here and here, a few fewer along the face. And you're going to start to get some really, really nice results there. For me, what's really great about this workflow that we have that takes you as far as the tin, by including those terrain layers, you're able to refine it to be exactly what you need. And then you can take the whole thing and export it out to LandXML. So for me, that's great. We can send this out to a LandXML file. It's going to do exactly what you need when you bring it into Civil 3D. So it'll recognize that as a Civil 3D surface and create everything. So that'll give you, for example, in Civil, your contours and all that other stuff for free. Of course, on our side, we're going to work on letting you create those contours directly. But since it's not there yet, we want to make sure that you've got a working workflow all the way through the rest of your deliverables that you need to be creating. One other thing that we just brought out in the release yesterday that I'm really excited about and I want to show you is road marking. So we've got this tool to automatically follow road paint. And this project is great, but it doesn't have a lot of paint in it. So I just wanted to quickly show you in here because I suspect that you guys in the region where you are have some nice big highway projects you can try this out on to see how it works. So let's see. I'm just on my laptop here. It's not amazing hardware. So what I'm going to do is actually save that, close it, and move on. So we're only looking at the highway, and then I will wrap it up. So this tool that we've got here, we've called it the road paint tool because that is what it is technically intended for, and it does really a nice job. So that is this symbol here, and it works on solid or dashed lines. If you're doing a dashed line like this one, then you do need to include 2 dashes. That's how it understands the spacing between the two. Let's see, I'm on layer 4 here, so we'll let that go. And you can see what this does is it just follows that paint as far as it can. Looks like it's still active. It's still going off into the distance there. And let's see, it actually stopped a bit sooner than I thought it would, but on the other hand, it got 400 meters in. So here's some other examples I did other days. We got 1 kilometer of paint with 2 clicks there. And let's just try one more while I'm here, because I think it should do a reasonably good job on this bit here. And you'll find it is a little bit color sensitive, which is the intent. It takes a moment to run, but on the other hand, quite often it will continue off around the corners. It can really, really save a lot of time in your vectorization. And it's just the first of the tools that we're going to bring towards letting you really work with all of this stuff in a much more automatic way. So definitely do give it a try. Let us know how it works out. And watch for some more tools. I know that, things that are a little bit more complex, like curbs, are difficult to capture, and we know that, and we want to let you be able to work with that both between the point cloud and the images. So we're going to really take advantage of the heritage we have as Pix4D of all those images and let you take advantage of that all the way through the process. So that's the last thing that I wanted to show you guys. I see we've got a couple minutes left. So I don't know, I'll throw it back over to you, Gabriele, if you have any closing words,
Nate.
anything you want to say?
It's very, very cool. And that's led basically to the automation that we wanted to do it in Pix4D. So that's just to inform everybody that here is the automation part for the vectorization. And Nate mentioned it quickly in the sense that we can also bring in and use LiDAR data or whatever else LAS source files into Pix4Dsurvey overlaid with the photogrammetry data, and these tools will work there anyway. So just quickly to wrap up, we have seen Pix4Dmatic processing next generation software for photogrammetry, very fast, reliable, and super user friendly. That fits perfectly into the workflow of a surveyor that goes from images to digitization with Pix4Dsurvey. So here we are for the Q&A session. And if you guys want, feel free to ask any question related to the FEDS topic as well. I mean, they are here as well. And we can reply to this. Jude, Dan. Oh, okay, so here we have not a question, it's just a thank you. Kamier is very nice. You talk to us. PPK or RTK, which one do you recommend? Guys from feds, you actually work directly on the field with this type of drones.
Yeah, correct. The system can depend on exactly which drones that we're engaging, but both systems are available, for example, with the EB. It does depend on the system, the project, and which drones are operating, to be honest. To be honest with you, that might be one of those questions we'd be better to get into a separate meeting and get into the nuts and bolts, because it's could be quite a long explanation.
Thank you.
Does anybody else have any other questions, please?
It seems that a lot of people are. Okay,
Sorry,
can I merge different photos taken from different height? Yes, it's possible. The important thing is to remember that you don't have to merge in one or to use in the same project images that are acquired at twice the distance from the ground. So if you're flying at 120 meters, it's not recommended to merge a data or to use in the same dataset for processing images that are acquired at less than 60 meters. This is simply for a GSD problem, and yeah, that's what we don't recommend. Definitely, you can merge these two datasets later on once the LAS file and the point cloud it's generated.
Camille, what we can offer you perhaps is a follow-on brief meeting, because obviously you have some great questions, and we'd be very happy to give you some direct technical support on some of your questions as well. Absolutely.
So also to enable the shy people that are maybe a little bit shy just to ask. So just it's good, and we can go for it. So for anyone who is interested to use the software and to test the software, Pix4Dmatic and Pix4Dsurvey, please just send an email to our friends in Feds over there in Dubai. They can support you, and they will be pleased to give you a 1 month free software trial for your tests, both for Pix4Dmatic and Pix4Dsurvey. So yeah. I'm really happy and very, very pleased that we have run this this project together, and this webinar. The recordings of this is going to be available upon request, I guess, from FEDS directly, and FEDS will inform everybody about that. So happy mapping.
Thank you very much, Gabriel. Really appreciate your input from yourself and all of the team today. I can see a few other questions are coming in now, so we'll follow on with everybody on these questions for the session. But thank you ever so much for everybody for attending. We look forward to the next in the series for Drone On, and we'll keep everybody updated. In terms of the offer for Pix4Dmatic, we will send that through to all of the attendees as well, so everybody can take advantage. And we'll come back to you personally to get into some of these questions with you, no problem. Okay, thank you very much, everybody.
Perfect. Bye-bye, and have a good evening.
Goodbye, everyone. Thank you.
Thanks all. Bye-bye.